Hi there, welcome to Averroes.ai's webinar. I am Omar Altamimi, Chief of Data Science at Averroes.ai. We'll be talking about our solution and how it can improve your visual inspection processes. In all sorts of manufacturing fields, whether it be electronics manufacturing, semiconductor manufacturing, automotive manufacturing, and any other industrial manufacturing application, we all strive to produce the best products without defects. We strive for quality. To bring facts to the matter, a study by the American Society of Quality stated that the cost of poor quality is 15 to 20% of the total sales revenue in manufacturing organizations. To ensure the quality of your product, we need inspection. There are many options when it comes to visual inspection. Doing it manually, for example, where you have workers manually inspect each workpiece visually. And then you have semi-automated inspection, where you provide those workers with tools that help them make more educated decisions and help accelerate their processes. And then you have automated optical inspection, which operates fully based on ingesting the feed from a camera and running it through an algorithm which makes decisions. We'll be focusing on comparing with the automated optical inspection in this webinar and how Averroes can improve upon such processes. But our solution is compatible with whatever kind of process you are using, whether it be manual, semi-automated, or automated. Now, automated optical inspection, or AOI, is a process that automatically detects defects in the product without the intervention of human inspectors. AOI systems typically involve three elements: the camera, the algorithm, and the actuator. For this webinar, we'll focus on the algorithm, which is the most critical element in AOI. However, the basic algorithm it employs suffers from multiple problems. The first of which is the accuracy. A big problem with the AOI algorithms is that they produce a lot of false positives, detections that optimally shouldn't exist, lowering the yield significantly. And to change anything in the algorithm, such as defining new product designs, detecting new defect types, one would need to restudy the entire problem from the start. The algorithm's quality and accuracy don't increase with time, but rather drop due to the drifting in the environment. And the change of any environment variable, such as brightness, noise levels, or small changes in the product design, can make the algorithm produce very bad results. And to construct the algorithm for AOI, you would need a domain expert with knowledge in artificial intelligence, as well as a lot of research time. More importantly, the collection of many images is also needed, by the magnitudes of hundreds to thousands. Furthermore, the labeling of such images takes a lot more time. Now that we've seen the downsides of traditional AOI, let's take a look at the solution. Averroes is a no-code, no technology required platform that's aimed at accelerating the integration of advanced AI into your manufacturing processes. It works as a purely software layer on top of your already existing hardware, taking in images from already existing cameras and enabling you to make better automated decisions, making no changes to your current processes while displaying the result in our graphical user interface for your review. But what does really make Averroes' models better? It has the following advantages. Averroes.ai produces models of the highest accuracy, meaning less false positives, less false negatives. After replacing an existing tool for one of our clients, the accuracy increased from 63% with their previous tool to 97% with Averroes software on top of their already existing tool. And then, when in use, the model actually suggests images that it finds interesting and requests your feedback on them. The model uses human-centric feedback as means to evolve and grow its accuracy even further. So that means you can start with a 95% accuracy model, and with active learning in the loop, you will be prompted to label a few images, and by labeling those images, the model will grow its accuracy to 98%, and then in the next iteration, it will grow to 99%, and eventually it will approach 100% accuracy. And if an unseen before type of defect, an anomaly, is first seen by the model, our models can detect it through the use of advanced AI models. That is to say that if there is a new defect type, as seen in the image on the left here, the model can actually detect it and assign it that type of anomaly. And then when the client sees it and actually labels it, gives it a name basically, then the model will actually learn from this immediately and start telling you, well, yeah, classifying other anomalies of the same type. Our models are also adaptive to the environment. Differences in brightness or placement do not reduce the accuracy of our solutions. That's to say that if the brightness, for example, differs from a normal setting, the predictions of the model will not change. The accuracy will not change at all. But what really makes us, capable of having all of these features is really the engine. Our engine is a tool that creates and designs models regardless of the use case. This enables us to auto-generate complex models in the matter of hours, while also ensuring that the results are of the highest qualities. And our models are boosted by our entirely in-house built defect GPT model that aids in the model design process. And then, when in use, the model actively learns from feedback or from images of interest that they find in the image feed through active learning. So to put it simply, Averroes takes your datasets and transforms them into the perfect model for AOI. And we do that in the following four-step process. First, we collect a few image samples from you, preferably 10 images or more per defect type. Then using that data, we input it into our engine, which generates high-quality artificial intelligence models in a few hours. And after that, when the model is trained and ready, it's ready to be used in the inspection process. And we'll explore the options of deployment in detail in the next slide. But it doesn't really end with deployment with Averroes. Our solution can grow using human-based feedback to continue pursuing 100% accuracy. So now, after generating the model, how do we get around to actually using it? The models generated by Averroes can be used on top of your existing AOI equipment. So that means it can read the image feed from the camera system or the file system and then run on top of that. The connection options can be separated into cloud and on-prem. Cloud solutions are optimal for clients that want to start as fast as possible with minimal hardware requirements. And we can connect with Azure, AWS, GCS, and Apple Cloud. As for on-prem, it's optimal for clients that want to keep their data in-house without any interaction with the internet for security purposes. Our on-prem solution can also connect to cameras in the local environment or the local file system. So, for example, we have an existing AOI machine which produces an image feed, and we can connect to that using either of the cloud or the on-prem options we discussed earlier. And after connecting to this image feed, we take it and we process it through our platform's pre-processing app and our deep learning models. Now, after we actually do the processing in real time, the outputs of the model will be fed back to the client side as well as displayed with statistics on Averroes' graphical user interface. So this is an example of a client that we had, and they had an existing inspection tool, but that tool missed 50% of the defects, yielding a 63% accuracy. When we came into the picture, we just connected to the existing tool's camera, automated their process with our solution, and our solution really only missed, it missed barely any defects, while yielding a 97% plus accuracy. So now let's take a look at a demo of the solution. So let me switch the scenes. Okay, so this is our dashboard. At Averroes.ai, we have a project-based approach where each project is a container for a set of relevant tasks. And each project has its own data, models, monitors, and connectors. Averroes also offers a team management feature, so the admin settings here, which allows you to invite collaborators to projects, as well as assign them different roles, controlling their access to data and settings. going back to the dashboard, we can create new projects by clicking on here and edit existing projects as well as delete them by exploring the options here. So given that, let's actually go into editing one of the projects here. So we can see that one project can contain multiple use cases in the form of data sets. And we can create new data sets by clicking here. So the important part here is the task type of the data set. The three options here indicate what is your end goal with the data set, right? So the options we have here are classification, which means that we expect a model that separates images into different classes. So given an image, it's going to tell me it's label A, it's label B, it's label C. Detection, which detects the location of the defects in terms of drawing a box around each defect. And segmentation, which goes a step further and returns the exact shape and outline of each defect within the image. So let's go back to the project. And these three tasks, actually, or these task types, they define what the data set is used for, right? So, for example, we have an interesting use case here. Which is the PCB inspection. The images you see here are images extracted from an AOI machine. The AOI tool or machine in question had a lot of false positives, and any change in the brightness or the perspective produced issues. So we came in to level up their inspection with advanced AI. So the task here was to detect instances of short circuits, of incorrect installations, or of dry solder joints. So first, we took a sample of images from their AOI tool and provided labels for them by using our in-house labeling tool. We can label any image by clicking on it simply. Okay, so now, once we're inside here, we can actually change the labels. So these boxes are the labels for this image. We can see perhaps that this box is a bit too big, so maybe we can make it smaller. And we created the draft version of the dataset. So we're changing this draft version. So you should not be worried about any changes you make on the draft version. So we see that this box is perhaps faulty. There is no short circuit inside. So we can actually delete this annotation. And for any other annotation here, we can actually change the type. And all of the annotations here, we can actually control the visibility of. And also in terms of visibility, we can change the brightness. We can change the contrast and the saturation of the images. This is useful for images with small defects, images that are hard to notice and require you to have, a higher saturation or higher contrast to actually be able to visually see the defects themselves. So we can actually go through the images in the data set, such like this, and change the labels. But once we're done with that, we can actually just go back to the data set. So once we're done with labeling a few images, actually, let's go to the version. Yeah. So we have this version, the draft version. And once we're done labeling a few images within the data set, we can begin the training process. But once we actually click on the train button, as we created the draft version of the data set, the draft version will be committed as a new version. So it will become a version 3, for example. So don't worry, though. Averroes will track all versions, and you can actually go back to version 1, for example, here, or you can go back to version 2 as soon as you create version 3 at any time. So if we click on train, the platform will prompt us to save the draft as a new version. So if we click on save, we'll actually see that version 3 was created, and now we are capable of training the model. So we actually have a few settings here. We're prompted to choose a few important features here to append to our model. So there's the active learning, which picks the most critical and important images to enable model growth and continuous learning. That means that we're essentially allowing the model to grow even further. There's also Watchdog, which allows us to detect never seen before defect types, aka detect new types of anomalies, new types of defects in the process, even if they were not defined in the initial labeling we've done here. And then there's Smart Augmentation, which uses AI to generate new samples of data based on your current labeled images. And this boosts the model performance. Now that we're done with picking the best options for us, we can start the training process. But as we've already trained the model for this use case, we can go into the models section. We can see that this model was trained on the first version of the dataset, and we can actually expand the training settings that were used for that model. And we can see that active learning was enabled on this model, as well as the watchdog. We can exit this. And we can see more performance information, such as the accuracy here. So we have a 97.41% accuracy on this model. And we can actually go into more info to view more detailed statistics and options. So if we click here, from here, the models page, we can see multiple important settings and stats. So first of all, we have the deployment options at the top, where we can connect the model to a camera for real-time streaming, or connect to a cloud storage or a local storage for automated predictions on newly uploaded images. On the on-prem, these options would translate to connecting to a local camera on the local network, or connecting to a local file system location or a NAS server for the storage. As for features, there's active learning, which is enabled on this model, and we'll explore it more in depth soon. But it basically enables our model to efficiently grow with more use. There's also the watchdog, which allows our solution to detect new, never before seen types of defects or anomalies. This is in contrast to solutions in AI machines, where the algorithms do not grow, and most importantly, you are incapable to configure the algorithms to detect any new type of defects or basic anomalies in the process. Furthermore, we can also generate API keys for custom prediction pipelines or manually upload a batch of images using batch prediction. We can also generate API keys. We can also test the model with a pre-uploaded sample of images or by dragging one in. So we click on here. The model is sampling some images of interest. So we can actually click on one of them, and the model actually evaluates this image, showing us what the model's performance looks like. These are the predictions, the output of the model. So we see that it drew a box around this short circuit, it drew another box around this short circuit, and there's also this box here. So now that we see that the model is actually producing expected results, we can scroll down and view stats, including the progress of the training process here, where the x-axis here describes basically time. So with more time, we see that the accuracy is increasing, and eventually it plateaus at 97.41, which is the final accuracy, which means that our model had sufficient time to train. And below that, we have type-specific information, so defect stats, where we can see the number of defects within each defect type, and then the number of detected defects out of those initial defects, the ones of correctly detected defects, aka true positives, the number of wrongly detected defects, so the false positives, and then the number of missed defects, the false negatives. And we can see this for any defect type we have here. And then there's the detailed metrics, where we can actually see stats per defect type. So we have here the accuracy, the precision and recall, and F1 score per each defect type. So now that we see that the model's accuracy is great, let's take a look at how we can effectively utilize it. In order to start utilizing and running the model automatically, you will need to connect it to a data source. In the connectors tab, so let's go there, we can define such connectors by clicking on Create Connector. And with that, we have pretty much covered most of the important features in the platform. Thank you for that, for your attention. And that will be it for the